look at some reactions that create enantiomers, diastereomers, and meso compounds. Here is an anti-addition, where two components are added to an alkene or alkyne from opposite faces. It's not an anti-relationship between two substituents of a molecule necessarily. They are two different uses of the term anti. The cis-alkene has no chiral carbons and is described as pro-chiral. When exposed to mCPBA, and that stands for meta-chloroperbenzoic acid, then acidified water, the pro-chiral alkene will be converted into a diol that has two new stereogenic centers. Let's take a look at this reaction in more detail. It occurs in 4 stages. First, mCPBA attacks the alkene in this situation from behind, leading to an epoxide facing behind the plane of the paper or here screen. Or, alternatively, mCPBA attacks from the front, with the resulting epoxide facing forward from the plane. Secondly, the lone pair of electrons on the epoxide oxygen abstracts a proton from acidified water. Next, water attacks the acidified epoxide, causing the ring to open and providing an alkoxonium alcohol intermediate that finally has its proton abstracted to form the ultimate diol. Okay, let's back up and see what's happening with all those arrows. We will begin by focusing upon the blue arrows. If water attacks either the upper carbon of the behind the plane acidified epoxide or the lower carbon of the in front of the plane acidified epoxide, the product is the same diol. But if we examine the red arrows, here the water attacks either the lower carbon of the behind the plane acidified epoxide or the upper carbon of the in front of the plane acidified epoxide, the result is the same. It is the enantiomer of the original diol formed with blue arrows. Where there is no other stereochemical influence, the enantiomers are in a ratio of 50-50. This is a racemic mixture. What happens if the same reaction is carried out upon a trans-alkene isomer? Here we see mCPBA attacking the alkene to give an epoxide behind the plane. But it's equally true for the forward-facing epoxide. This is because when either has its ring opened by the attack of water, the diol formed can be easily seen upon rotation of the central carbon-carbon bond to have a plane of symmetry. So it is meso. Syn addition is where two components are added to an alkene or alkyne from the same face. This cis-alkene is reacted with osmium tetroxide, then sodium hydrogen sulfate, to provide a 1,2 diol that has a plane of symmetry and is meso. The trans-alkene reacts under the same conditions of osmium tetroxide followed by sodium hydrogen sulfate to give a pair of 1,2 diols that, as mirror images of each other, here are enantiomers. In summary, cis-alkenes with the same R group on either carbon with an anti-addition form a racemic mixture of enantiomers. When a trans-alkene with the same R groups on either carbon reacts through a syn addition, a racemic mixture of enantiomers is also generated. When a cis-alkene with the same R groups on either carbon with a syn addition forms a meso isomer. This is the same result as when a trans alkene with the same R groups on either carbons react through an anti-addition to also give a meso compound.